Hey guys, welcome to Zee Cynex CCNA series, Day 1. In this course, I will guide you from basic to advanced networking concepts and configurations. By the end of this certification, not only will you be ready to work as a network administrator, but we will also perform a complete project together where you will apply all the knowledge and skills you have learned. Since this is our first class, before moving into networking basics, let's first take an introduction to CCNA. CCNA stands for Cisco Certified Network Associate. This certification validates your knowledge of networking fundamentals and practical skills. It provides a foundation not only for networking but also for cybersecurity and cloud related careers. Whether you are new or already have some background, CCNA is perfect place to start. Let's start about topics we will cover in this certification. Networking fundamentals. We will begin with networking fundamentals, where we will learn about IP addressing, subnetting, and different routing protocols. These are the building blocks of networking. Next, we will cover network access. This includes VLANs, switch configuration, and access control, important for managing traffic inside a network. Then we will study IP connectivity, focusing on routers, OSPF, and static routes. These topics will show you how devices communicate across networks. After that, we will move to IP services such as NAT, DHCP, and quality of services. These services help with address translation, automatic IP assignment, and quality of services for smooth network performance. We will also learn security fundamentals, including firewall concepts, VPNs, and access lists. These are crucial to protect networks from threats. Finally, we will explore automation and programmability. This includes SDN, Cisco DNA Center, Ansible, Terraform, REST APIs with CRUD, CRUD operations, JSON, and XML, and even how AI and machine learning are used in networking. This certification proves you have essential networking knowledge and hands-on skills. It gives you a strong base to grow into networking cybersecurity roles. You should be comfortable using a computer and basic software. No prior degree or certification is required. Just genuine interest is enough. You will need a system with packet tracer or GNS3 installed so we can practice labs. Let's talk about exam details. This is official exam code for CCNA certification. You will have 2 hours to complete the exam. The exam include multiple choice questions and simulations to test both knowledge and practical skills. The fee is about $300, but it may vary depending on your country. Getting certified open up better career opportunities. CCNA holders usually earn more and are preferred over non-certified professionals. So let's start our day 1, networking basics. What is network? The process of connecting two or more devices so they can communicate and share resources. This can involve wired connection such as Ethernet cables or wireless connections such as Wi-Fi. Let's discuss the networking types. There are mainly 3 types of networking: LAN, MAN, and WAN. One by one, we will discuss these types of networking. A local area network or LAN is used to connect devices in a small, limited area, like a home, an office, or a campus. It is designed for short distances. In a LAN, devices such as computers, printers, and servers can talk to each other. For example, you can send a file to the printer or access data stored on a server. The one of the biggest advantages of LAN is resources sharing. Instead of every computer needing its own printer or internal line, devices can share a single internet connection, share file quickly, and use shared hardware like printers. Here are some key points of LAN. Ethernet cables in a LAN can go up to 100 meters per segment using Cat5e or Cat6 cables. With Wi-Fi, the range depends on frequency. 2.4 GHz works around 45 meters indoors and 90 meters outside. 5 GHz covers about 30 meters indoors, shorter range but faster speeds. LANs provide high-speed connection for quick data transfer. They allow easy sharing for files, printers, and internal among devices. LANs give administrator more control over devices and security in a small area. MAN. A metropolitan area or MAN covers a whole city or town. It's bigger than a local area network, but smaller than a wide area network. It joins together several LANs. For example, the LANs in different office buildings of the same company, so they can communicate easily. Businesses use MANs to connect their offices across a city. Universities use it to connect different campuses. And government agencies use it for city-wide communication. Because it links multiple LANs and MAN provide high-speed and reliable data transfer across the city, making collaboration much easier. WAN, a wide area network, or WAN, covers very large areas. This could be across a region, a country, or even worldwide. The internet itself is the best example of a WAN. It links together many local area networks and metropolitan area networks. For example, the head office LAN of a company in one city can connect to branch offices in other countries through a WAN. WANs allow people and organizations to communicate and share data across long distances. For example, employees in different countries can work on the same project using a WAN connection. Any business of government agency with offices in multiple locations rely on WAN to stay connected and share resources effectively. So now let's start about network topologies. Network topology simply means the structure or layout of how devices are connected in a network. There are some main types we will discuss in this video one by one, like bus topology, ring topology, star topology, and mesh topology. What is bus topology? A bus topology is a linear arrangement of devices connected to a single cable, with each device linked through a T connector. It's simple and cost effective to set up. If the main cable fails, the whole network goes down and performance decreases as more devices are added. What is ring topology? A ring topology is circular arrangement of devices, with each device connected to two other devices, forming a closed loop. Data flows in one direction, reducing the chances of packet collisions. If any network device or connection fails, the entire network can be disturbed. Star topology. A star topology is central device connected to several devices, with each device connected to the hub or switch by a separate cable. In the star topology, if we use a hub, it broadcasts data to all devices, which is less efficient. A switch, on the other hand, making it smarter and faster. We will discuss this in our lab. And in practice, we will use switches more than hubs. If one device fails, the rest of network keeps working. If the central device fails, the whole network stops. What is networking media? Media or medium in networking refer to the physical path or channel through which data travels from one device to another. There are two types of media. Wired medium. This includes cables like coaxial, twisted pair, and fiber optic that physically connect devices. Wireless media. This uses signals such as Wi-Fi or radio waves to connect devices without cables. Let's briefly discuss the types of media. Coaxial cable. Coaxial cable are commonly used in cable television and CCTV connections. They use a BNC connector which securely locks the cable in place. Coaxial is less common in modern labs. Fiber optic cables. Fiber optic cable is a high-speed transmission medium that uses light signals to carry data. Let's discuss types and distance. Single mode fiber can carry data up to around 40 kilometers, while multi-mode fiber is generally used for shorter distance above 2 kilometers. We usually use fiber for long distance and high-speed connections, but in smaller networks, it is less common compared to twisted pair cables. Here we can see, here is the single mode distance and application. Means here are the types of fiber optic cables and the bandwidth they can carry. Twisted pair cabling. Twisted pair cables are made of pairs of wires twisted together to reduce interference. They are the most common cables used in LANs. Here are two types of twisted pair cabling. UTP, unshielded twisted pair, is cheaper and widely used in home and offices. Shielded twisted pair has extra shielding to protect against interference used in environments with more electrical noise. Here you can see the category of twisted pair cabling and their data rate, bandwidth, and max distance, and how much data can carry a category. What are the data transmission modes? Data transmission modes refer to the direction in which data flows between devices in a communication channel. There are three primary modes: simple mode, half duplex mode, and full duplex. Let's briefly discuss one by one. Simplex mode. Simplex mode is one-way communication system where data flows only in one direction. It's unidirectional, meaning one device only sends and the other device only receives. A good example is keyboard sending input to a computer. Half duplex. Half duplex is a communication mode where data flows in both directions, but only one side can send at a time. It is bidirectional, but not simultaneous. Devices take turns to communicate, and a protocol is required to manage this turn taking. A good example is a walkie talkie. Full duplex. Full duplex is a communication mode where data flows in both directions at the same time. It is bidirectional and simultaneous, which means both devices can send and receive data together. A common example is telephone call. Thanks for watching. Don't forget to subscribe to Zee Cynex for more tech tutorials, networking deep dives, and hands-on practice. See you in the next session.